so let's look at this problem. So it says when 28.6 kilograms of carbon are allowed to react with 88.2 kilograms of TiO2 in the reaction below, and I have the reaction, 42.8 kilograms of Ti are obtained. Find the limiting reactant, theoretical yield, and percent yield. And then I give you the reaction. So we got a lot of stuff going on. So what are we looking for in this problem? So I'm looking for the limiting reactant, the theoretical yield, and the percent yield. Okay, so I'm looking for those three things. So now I know, oh, this is a limiting reactant problem. So I can kind of think about limiting reactant procedure. So then I want to know, what do I have? So one thing I like to do when I have an equation like this is I like to take all the numbers and put them where they go. So it says 28.6 kilograms of carbon. So I find the carbon and I write it underneath. It visually helps me see what I have. 88.2 kilograms of TiO2. Okay? And 42.8 kilograms of Ti. So now I have everything kind of written out. So now I can visually see what's going on. All right, so the first thing I need to do is I need to figure out what the limiting reactant is. So to figure out the limiting reactant, it's got to either be this guy or this guy. So to figure out who's the limiting reactant, I have to take the reactant and I have to go to product. Then I have to take the other reactant, go to product, and see which one gives me the least amount. So I say, okay, all right, I need to go from TiO2 to product, but which product do I go to? Now, in this case, you could go to either one, but it would be easier, since I know I'm going to do percent yield later, to go to the one they tell me something about. So they tell me something about Ti, and I'll explain what this is in a little bit, okay? So if they tell you about one of the two, that's kind of your hint that when you're doing limiting reactant, you'll save time if you go to that one. All right, so I'm going to go from here to my product. I'm going to go from this one to my product. So 2 different times. I'm going to see which one gives me the smallest. So the only way I could go from TiO2 to Ti is through the mole. And I have kilograms. So how do I get to the mole if I have kilograms? What do I have to do first? I need to change my kilograms to grams. What is kilo? It's 10 to the third. Does it go on top or bottom? It's going to go on the opposite side of the prefix, so it's going to go on the top. So now I'm in kilograms. Okay? But now I've gone to grams from kilograms. But I don't want grams, I want moles, because I'm trying to switch guys, and the only way I can switch is when I'm in moles. So I want to go from grams of TiO2 to moles of TiO2. How do I go from grams to moles? The periodic table. So I have to add it up on the periodic table. So you go to the periodic table, you find the mass for oxygen right here times 2, and then the mass for titanium right here, and you add it up. So when you add it up, you get 79.87. Does it go with moles or grams? It's going to go with grams. I'm going to slide this over. So you get 79.87 grams of TiO2 per 1 mole. So my grams came. Now I'm in moles. Now that I'm in moles, moles is the only way that I can go from my reactant to my product. So now that I'm in the right units, now I can switch which one I'm in. So now I could go from moles of TiO2 to moles of Ti. All right? And so let's talk about the relationship there. How many TiO2s? 1 to 1. So it's a 1-to-1 ratio. A 1-to-1 ratio. So I put that in, and now I can do the math and get moles of Ti. So this is going to give me 1.1043 times 10 to the third moles of Ti. All right, so that's like taking your bread or your cheese and finding out how many sandwiches. And this is just stoichiometry, going from one thing to something different, only through the mole to mole. Now I need to do the exact same thing starting with carbon and going to Ti. So same process, but I start with carbon. So 28.6 kilograms of carbon. I need to go from kilograms to grams. Kilos 10 to the third, it goes on top. Now I have grams of carbon. I don't want grams, I want moles. Grams of carbon go on the bottom, moles of carbon go on top. I want to go from grams to moles. I do that using the periodic table. So I go to the periodic table and I find carbon. Carbon is 12.01. Does that go on top or bottom? It goes on bottom. So now I can go from grams to moles. So now I'm in moles of carbon. So now that I'm in moles of carbon, now I can change from being in carbon to TI. Now I can change who I'm in. So now I need to know what that ratio is, that relationship. For every 2 carbons, there's 1 TI, so it's a 2-to-1 ratio. So every 2 carbons, there's 1 TI. So now I can do the math, and I can get that number. So for 28.6 kilograms of carbon, I got 1.1907 times 10 to the 3rd moles of TI. All right, so we wanted to find the limiting reactant. So I took my bread, went to product, took my cheese, went to product, or whichever one. Now I need to figure out, well, how much am I actually going to make? So which one is the smaller number? So they're both 10 to the 3rd, so I just have to look at the number in front. This is 1.10, this is 1.19. So this is the smaller number. So we're going to want the smaller number, that's the one we want. We don't want this one. The smaller number is produced by what? So TiO2 is my what? It's my limiting reactant. So we just figured out that the limiting reactant is my TiO2. So now I figured out this one. So what would be the carbon? The carbon would be the excess reactant. Okay? So this is the limiting reactant, this is the excess reactant. Okay? So now I know who is the limiting reactant. The next thing I want to find is the theoretical yield. Okay? So I have the theoretical yield because the theoretical yield is the number that's lower in my comparison. So this is the theoretical yield. Okay? So technically I have the theoretical yield. I'm done. But I might ask you it in different units. This is in moles. So in my problem, I just want to go ahead and put it in kilograms. And you'll see why we really want that in a second. So I don't need this. I have some blank slides, like the next slide's blank for you. But it's just easier if you can still see everything. So I'm going to leave it up here. You can write it on the next slide. All right. I want these units to match these units. So I want to put that in kilograms. So this is my theoretical yield, but I'm just converting this theoretical yield into the correct units. So it's in moles and I want to get to kilograms. So what do I do first? I can't go moles straight to kilograms, but I can go moles to grams. So I have moles of TI, but I want grams of TI. How do I go from moles to grams? Periodic table. So I go to the periodic table, find TI, 47.87. Is that going to go on top or bottom? Goes with the grams, so it's going to go on top. 47.87 grams in 1 mole of TI. So my TI cancels. Now I want to go from grams to kilograms. We said kilo is 10 to the 3rd. It goes on the other side of the prefix. So that cancels, and I get 52.9 kilograms of TI. And this is my theoretical yield. So now I have that guy. So now I have my limiting reactant, and I have my theoretical yield. All right, so the next thing I want is my percent yield. So what was the percent yield? So it says I want the percent yield, but what was the formula for percent yield? It was the actual yield divided by the theoretical yield times 100. All right, so if I'm doing this, the first thing I need is the actual yield. So how much do I actually have of my product? So what's the product? The product is the TI, right? So how much do I actually make? This is not something you can calculate. The actual yield is something that you have to find by actually doing the experiment. Well, since we're not doing this experiment, I can't just go do the experiment and find out. So that means the actual yield has to be given to you in the problem. So remember I said we would go back to this number. They told me how much was obtained. 42.8 grams of TI was obtained. That's how much product we got. This number is the actual yield. So they always have to give it to you because you can't find it any other way. Okay? So 42.8 is my actual yield. Then we want the theoretical yield. So we have the theoretical yield here in moles, but we converted it in kilograms. Now you might say, well, why did I do that? The reason I ended up doing that is because these units have to be the same. So if I want to put the theoretical yield in here to calculate the percent yield, my units have to be the same. So if I were to put the mole unit in there, I couldn't calculate the percent yield because those units have to cancel. So that's why I needed to put my theoretical yield in the same units as my actual yield. So my theoretical yield is 52.9. And remember, what did we say? The actual yield is generally less than the theoretical yield. So we kind of know that's right, okay? So then we do the math and we get that the percent yield is going to be 80.9%, which is good. Your percent yield should be 80 or higher. That's what you kind of want. Unless you're doing organic chemistry, then you're happy with like a 20% yield. Because some things just, you got a lot of steps and it's going to create a lot less. Okay? Now, if you accidentally flip this, you would get over 100. We don't want over 100. So if you ever get over 100, you either did the formula wrong here or you did the math wrong somewhere. Or if it's in a lab scenario, then it's contaminated. Okay? So we never want over 100%. That's kind of how we know if it's off or something of that nature. All right, so that is theoretical yield with everything possible. Okay? And I found the limiting reactant, I found the theoretical yield, I put them in the correct units, and I found my percent yield. So this is as long as a theoretical yield problem can get, a limiting reactant problem can get, because this problem we found everything in it. All right, now this problem helped you because it said limiting reactant in the problem. But what if I don't tell you that it's a limiting reactant problem? How do you know it's a limiting reactant problem without me directly telling you? And that's what we're going to look at on the next lecture.